In this video, we're solving problem 12.1.069 from the Larson and Edwards Calculus Early Transcendental Functions text, 7th edition. We're asked to find the limit if it exists. If the answer does not exist, we're asked to enter DNE and WebAssign. We have the limit as t approaches 0 of this vector valued function. Remember, the function multiplying I hat is x of t. The function multiplying j hat is y of t. And the function multiplying k hat is z of t. And evaluating limits of these is pretty simple. All you have to do is take the limit of each component separately. I prefer component form rather than this notation in terms of standard unit vectors, I hat, j hat, and k hat. So I'm going to write this a little differently. I'll say that this is the same as the limit as t approaches 0 of the vector with components 8t, sine of 7t divided by 7t, and e to the negative 4t. And provided these limits exist, this is equal to this result. You take the limit of each component separately, multiply those guys by I hat, j hat, and k hat, and then you're done. Then that is the limit of the original vector valued function. Well, when I'm taking this limit, I've got the limit as t approaches 0 of e to the 8t. Now, it's been a while since pre-calculus or college algebra. E to the 8t looks like this. When t equals 0, e to the 8t is 1. Looks just like the e to the t graph, but it's changed a little bit by that factor of 8 that's inside. Actually, multiplying the t value by 8 compresses the graph horizontally or stretches the graph vertically, and it's related to that 8 there. But I'll leave those details for college algebra. This is the basic shape of the graph. The function's continuous. When you plug in t equals 0, you get e to the 8 times 0. E to the 0 is 1. And so this limit is 1. And this guy is very similar. E to the negative 4t looks like this. Since that exponent is negative, the function is decreasing. And when t equals 0, y equals 1. So again, when I take this limit, I just get 1. Now this one is the most challenging part of this. If you substitute t equals 0 into this function, you're going to be in trouble because we'll have sine of 0. And remember, sine of 0 is 0. That's what the sine graph looks like on the period 0 to 2 pi. And it continues forever in both directions, just repeating itself over and over again. So that numerator is 0. And as t approaches 0, the denominator is also approaching 0. So this is a 0 over 0 indeterminate form. Now you might remember from Calculus 1 that the limit of this function is 1. The limit of, as theta approaches 0, of sine of theta over theta is 1. That's just a fact that we memorized in Calculus 1, and then we could also prove it by looking at, well, we were looking at circular sectors and looking at some things related to trigonometry. But after that, we were able to prove it another way. Whenever you have a 0 over 0 indeterminate form, you can use L'Hopital's rule to evaluate that limit. So let's do this off to the side. We're taking the limit as t approaches 0 of sine of 7t over 7t. And since that is a 0 over 0 indeterminate form, that means that there is more work to do. If we don't remember the fact from Calculus 1 that this limit is 1, we can confirm that the limit is 1 using L'Hopital's rule. Now, according to L'Hopital's rule, and we put an h over that equals sign to indicate that we're applying L'Hopital's rule here, the limit of this function is the same as the limit of this function. You take the derivative of the numerator, derivative of sine of 7t, as cosine of 7t, the derivative of sine is cosine, times the derivative of the inside by the chain rule, so that's a 7, all divided by the derivative of 7t. The derivative of a constant times t is just your constant. The 7's reduce, and then you have the limit as t approaches 0 of cosine of 7t. Now the cosine graph looks like this. When t equals 0, the cosine function equals 1. And so we get cosine of 7 times 0, or cosine of 0, which is 1. So this 0 over 0 indeterminate form turns out to have a limit of 1. So the answer to this question is a vector. Because we're taking the limit of a vector valued function, the result is a vector. It's a vector with components 1, 1, and 1. Or in terms of I hat, j hat, and k hat, that's 1 times I hat plus 1 times j hat plus 1 times k hat.